Greetings, I'm Brien Posey, and in this presentation I want to talk about what's new in HyperV 3.0. Before we get started, I want to give you a little bit of information about me. I'm a freelance technical author and industry analyst. I'm a 9-time Microsoft MVP. I've won the MVP award in several different areas over the years, including file system storage, which is my current MVP area of specialties, also Exchange Server, Windows Server, and IIS. Before I went freelance, I was a CIO for a nationwide chain of hospitals and healthcare facilities, and I've also served as a network engineer for the Department of Defense at Fort Knox. Prior to that, I worked as a network administrator for some of the nation's largest insurance companies. So my agenda for this presentation is pretty simple. I'm going to start out by giving you a brief history of HyperV, and then from there I'm going to turn my attention to talking about what's new in version 3.0. HyperV has a relatively short release history. It was first introduced with Windows Server 2008 just a few years ago. After that, Windows Server 2008 R2 continued to include HyperV, and Microsoft's made some very welcome changes because the original 1.0 release that came out with Windows Server 2008 only offered basic functionality. The 2.0 release, which was the Windows Server 2008 R2 version, had a few enhancements. The two most important of those enhancements were live migration. That's the ability to move a running virtual machine from one host server to another, and memory over commitment. Memory over commitment was the ability to allocate more memory to virtual machines than what was physically present within the host server. So those were the two big changes that came about with version 2.0. Now, with Windows Server 2012, Microsoft is releasing HyperV 3.0. And HyperV 3.0 is going to include hundreds of new features. Obviously, I won't be able to cover all of these new features within this webcast, but I'm going to talk about the most important ones. But with version 3.0, HyperV is finally going to become an enterprise-class hypervisor, and you'll see why as I go through talking about some of the new features. Before I get started, I need to quickly point out that throughout its entire release history, HyperV has been offered in two different editions. There's a free standalone product, but you can also run HyperV as a service on top of Windows Server 2008, 2008 R2, and now with HyperV 3.0, Windows Server 2012. So this presentation, I'm only going to focus on HyperV as a service, that is HyperV 3.0 running on top of Windows Server 2012. So ever since Microsoft first started previewing HyperV 3.0, the one question that I've been asked more than any other is, did Microsoft finally get it right this time around? And I'm happy to say that I really do think that they did get it right. HyperV 3.0 finally has enterprise-class features, and the features that are found in HyperV 3.0 are comparable to what's in VMware 5. As a matter of fact, if any VMware administrators are watching this webcast, I'm sure that some of this is going to look very familiar to you. But one of the things that made me the happiest about HyperV 3.0 is that in spite of all of these new features that Microsoft is introducing, they still managed to keep the interface for HyperV 3.0 very simple and intuitive, and in fact the interface looks a lot like what we had with HyperV 2.0. Let me show you what I mean. The main tool for managing HyperV has always been the HyperV Manager, which you can see right here on the slide. As you can see, the console tree is divided into several different panes that I want to quickly show you. On the left we have the console tree, and the node that's selected is the HyperV server. The top of the middle pane lists all of the virtual machines that are installed on this server. Here we can see not only the virtual machine names, but also which virtual machines are running, and how much CPU time and how much memory those virtual machines are consuming. The center pane lists all of the snapshots for the selected virtual machine. Right now no snapshots are showing up because the virtual machine that's selected doesn't have any snapshots. Down at the bottom center pane is the review, and this basically just tells you when the virtual machine was created and any notes for the virtual machine. In the actions pane off to the right, we've got two sections. The top section shows you all of the different actions that you can do for the host as a whole. We can do things like importing virtual machines, creating new virtual machines, modifying the HyperV settings, and things like that, things that are specific to the hypervisor. The lower right pane gives you options of things that you can do to the virtual machine that's highlighted. We can do things like connecting to the virtual machine, modifying the virtual machine settings, starting the virtual machine, creating snapshots, and exporting the virtual machines, and other things like that. So this is just a really quick overview of the HyperV Manager as it existed in HyperV 2.0, just so that you have that for reference purposes. So with that said, take a look at the HyperV Manager for version 3.0. It follows the same basic layout as what you just saw for HyperV 2.0. We have the console tree on the left. The top middle pane is listing all of the virtual machines that are installed. And then we have the snapshots and the virtual machine previews. And then off to the right, we have the actions pane for the hypervisor as a whole. And in the lower right, we have the actions pane for the currently selected virtual machine. So this is exactly the same layout as what we had with HyperV 2.0. And this is a big part of why I say that Microsoft got it right, because HyperV 3.0 contains an endless array of new features. I mean, there are countless features that have been added, and yet Microsoft managed to keep the same simple interface that they always had. As a matter of fact, when you're looking at this screen right here, the only really notable change that you notice is down in the lower center pane. Whereas that pane used to just be the summary for the currently selected virtual machine, we now have some tabs. We have summary, memory, networking, and replication. So some of the new features are exposed through these tabs down at the bottom of the screen. But most of the features are implemented very logically through the different property sheets and setting screens and things like that you'll encounter as you create and work with virtual machines. I think Microsoft did an incredibly good job of creating this console. Now, I could go on and on about the HyperV Manager, but the big news isn't that Microsoft has a new version of the HyperV Manager. That's totally to be expected. The big news is that now you can fully manage HyperV and all of your virtual machines through PowerShell. If you take a look at the slide right here, you can see that I entered the get-vm command, and when I typed in that command, PowerShell returned the names of all of the virtual machines that are on the host, their state, in other words, which virtual machines are running and which ones are turned off, the CPU usage, the memory assigned to the virtual machines, how long they've been up, and whether or not they're operating normally. And this is actually just the tip of the iceberg. There's a whole lot more information that we can acquire from virtual machines. And we can even do things like starting and stopping virtual machines. If you look at the bottom of this pane, you can see I've entered the start-vm VM3 command, and that actually starts the virtual machine VM3. So this is just a rough sampling of a couple of things that you can do. The PowerShell interface is very, very powerful, and you can do all sorts of things with your virtual machines. Now, in all fairness, this was possible in HyperV 2.0, but the option to use PowerShell to manage HyperV and the virtual machines wasn't built in. There was actually a separate download that you had to go and get, and you had to install this add-on module so that you could manage HyperV. Now, all of this functionality has been included natively within the operating system. When I talked about the HyperV release history, I mentioned that there were two big new features that came out with HyperV 2.0, memory over commitment and live migration. So I want to talk about those two features first and talk about how HyperV 3.0 builds on what was already there with HyperV 2.0. So memory over commitment still exists with HyperV 3.0, and the reason why that exists is because memory over commitment allows you to allocate more memory to your virtual machines collectively than what's physically present within the system. By doing this, you're able to increase your virtual machine density and improve your overall return on investment for your server hardware. Now, that's great, but memory over commitment had one fatal flaw within HyperV 2.0, and that fatal flaw has something to do with the way that Windows works. When Windows starts up, it usually consumes more memory at startup than it does when Windows is just idle and not really doing anything. The problem is that the memory over commitment feature in HyperV 2.0 treated startup memory and minimum memory as the same thing. So your startup memory was the minimum memory. There was no way that the virtual machine could ever use less memory than what it used at startup. This is all changed in HyperV 3.0. In 3.0, Microsoft introduced a feature called memory ballooning, and memory ballooning is the same thing as memory over commitment, except now startup memory and minimum memory have been broken apart and they're treated as two completely separate things. So you can claim the memory that you need at system startup and then release some of that memory as the virtual machine stabilizes and goes idle. So this can help you to use HyperV memory a lot more efficiently. So to make the concept of memory ballooning make just a little bit more sense, what I've done here on this slide is to take the virtual machine settings screen from HyperV 2.0 and put it right next to the virtual machine settings screen for HyperV 3.0. And I've selected the memory configuration option, and you can see that both HyperV 2.0 and 3.0 support the use of static or dynamic memory. Now, if you enable dynamic memory, then HyperV 2.0 lets you specify startup RAM and maximum RAM. But if you look over at HyperV 3.0, you can see that we've got some different options. We've still got startup RAM and maximum RAM, but we also have a minimum RAM option, and you can set the minimum RAM to be lower than the startup RAM so that Hyper-V is able to reclaim some of that memory that gets used when Windows is starting up within a virtual machine. So that's what memory ballooning looks like, especially with regard to the Hyper-V Manager interface and how you would implement memory ballooning. The other big new feature that was released with Hyper-V 2.0 was live migration. Live migration refers to the ability to move a running virtual machine from one host server to another without taking that virtual machine offline and without having any interruptions in service. Now, in Hyper-V 2.0, live migration was a serial operation. What this means is that you could only live migrate one virtual machine at a time. If you had 10 different virtual machines that needed to be live migrated, you had to do those one at a time and do them in sequence. You couldn't do parallel live migrations. This has changed in Hyper-V 3.0. Now it's possible to live migrate multiple virtual machines all at the same time. Now, the actual number of live migrations that you can perform concurrently depends greatly on how much bandwidth you have available. But Hyper-V 3.0 has an interface that you can actually use to set the maximum number of live migrations that you want to allow to be performed concurrently. I'll show you what that looks like on the next slide. So in this slide, you can see the Hyper-V settings page for a virtualization host. And if you look towards the middle of the pane on the right, you can see that we have the option to specify how many simultaneous live migrations we want to allow. Right now, this is set to 2, but you can adjust this value up or down depending on how much bandwidth you have available. Now, if you look directly underneath of that, you'll notice that we have an option called Incoming Live Migrations, and we have the option to either use any available network adapter for live migrations, or we can specify the IP address that we want to use for live migrations. And the reason why this is available is because you may not necessarily want to do live migrations over every network adapter, because doing that could impact production workloads if you've got virtual machines that are depending on network adapters to do their jobs. Another thing that I want to show you is at the top of this dialog box on the right, we have the option of selecting an authentication protocol. We can use credential security support providers, or we can use Kerberos-based authentication. So we've got several different options with regard to how live migrations are configured. Microsoft has actually done a tremendous amount of work around live migrations beyond what you've already seen. One of the big changes to live migrations is that with previous versions of Hyper-V, it was only possible to live migrate a virtual machine within a virtual machine cluster. You could move a virtual machine to another cluster node, but you couldn't move it anywhere else, and you couldn't do live migrations from non-cluster members. In Hyper-V 3.0, that limitation goes away. Now it's possible to live migrate a virtual machine to a host that exists outside of a cluster, or you can live migrate from outside of a cluster into a cluster. So you have ways of moving virtual machines around with a tremendous amount of flexibility. This is something that Microsoft refers to as shared nothing live migrations. Now, it's important to note that shared nothing live migrations shouldn't be used as a long-term replacement for a traditional failover clustering solution. It's more a convenience feature that you can use to move virtual machines around and get them where you need them to be. Now, I don't want to get too technical because this presentation is designed to be a light overview of the new features in Hyper-V 3.0, but I do at least want to mention that there are some requirements that you have to adhere to be able to do shared nothing live migrations. The shared nothing live migrations don't happen by magic. Your host servers have to meet certain criteria. The first of those criteria is that you have to have at least 2 Hyper-V 3.0 hosts. Those can be standalone hosts or they can be clustered. It doesn't really matter. The next requirement is that each server requires adequate storage. This can be local storage or it can be remote storage in terms of SMB. The third requirement is that hosts must have the same family or type of processor if you're using the processor compatibility feature. Next, hosts must exist within the same Active Directory domain. If you've got hosts in different domains and you want to live migrate between those, well, that's not something that you're going to be able to do, unfortunately, at least not with this version of Hyper-V. The next criteria is that the hosts have to be connected to each other by a gigabit or faster network link. Live migrations are bandwidth intensive, and you have to have that gigabit or higher network link to facilitate shared nothing live migrations. Another requirement, and this is a biggie, is that the host have to have the client for Microsoft Networks and the file and print sharing service for Microsoft Networks enabled. Otherwise, shared nothing live migrations won't work. Also, pass-through storage can't be used because that can't be live migrated. And both machines that are involved in the shared nothing live migration have to have the same virtual switch configuration. So those are, in a nutshell, the requirements behind making a shared nothing live migration work. Another huge change that Microsoft has made with regard to live migration in HyperV 3.0 is that now shared storage isn't required anymore. It's recommended that you use shared storage for performance reasons and for reliability, but you don't have to. In HyperV 2.0, you had to have what was known as a clustered shared volume. This was shared storage that could be used by all of the hosts within the virtualization cluster. That requirement no longer exists in HyperV 3.0. Now, instead of using shared storage, you can actually use local storage and perform live migration across an Ethernet cable. So this is a huge new feature for HyperV 3.0, and it's one of the centerpieces of the new hypervisor. So as you can see, a great number of the enhancements that Microsoft has made in HyperV 3.0 are related to failover clustering. Obviously, the ability to do live migrations without the need for a shared storage or a clustered shared volume is huge. But there are also other improvements that Microsoft has made. There are tremendous scalability improvements, and I'm going to be talking about those a little bit later on. Another area where Microsoft has enhanced HyperV 3.0 is with regard to storage migrations. Now, storage migrations are different from live migrations. Live migrations involve moving a running virtual machine from one host server to another. Storage migrations involve moving the virtual machine components, that's specifically the virtual hard drive files and the components that make up the virtual machine, moving those from one storage location to another. That's what a storage migration is. Now, storage migrations existed in HyperV 2.0, and they were referred to as quick migrations, or quick storage migrations, rather. But the downside to quick storage migrations was that there was a brief outage that occurred at the end of the storage migration, while HyperV switched over to using the new location. In HyperV 3.0, that limitation's gone. Now, storage migrations actually occur without any downtime at all. So, storage migrations can now be referred to as storage live migrations, because the process really is done live with no downtime. One of my personal favorite new features in HyperV 3.0 is something known as HyperV Replica. HyperV Replica refers to the ability to replicate a running virtual machine to another host. This host can be a standby HyperV server, and it can exist in the local data center, or it can exist off-site in a remote data center. The nice thing about Replica is that it works really well in high latency environments or in environments where connectivity is not always reliable, such as over an internet connection, and you can actually replicate a virtual machine over a connection like that. Now, the replication isn't real time. You're not going to see changes that you make in the primary virtual machine show up instantly in the replica, but it's near real time. There's actually an adjustable schedule that controls how frequently changes are replicated. Generally, virtual machines are going to be replicated at 5-minute intervals, but there are a number of different factors that can affect this. One thing that you need to know about the HyperV Replica feature is that this isn't a failover clustering solution. When a failure occurs in the primary data center, the replica is not going to automatically take over, although it can if you go through a manual process to activate it. HyperV Replica is more intended as a disaster recovery solution. In other words, if something goes wrong in your primary data center and you lose a virtual machine, you can use the replica to get the contents of that virtual machine back. So HyperV Replica is a very powerful feature, and it brings enterprise-class replication to small businesses that would have been totally unable to use a feature like this previously because it would have been financially out of reach. Another new feature that hasn't really received as much press as some of the other features, but that I'm excited about nonetheless, is something called Virtual Fibre Channel. Virtual Fibre Channel will allow virtual machines to connect directly to Fibre Channel storage through a virtual SAN. Now, Virtual Fibre Channel is based on something called Import ID Virtualization Mapping, or NPIV as it's often abbreviated. So because of that, what that means is that physical Fibre Channel host bus adapters must support NPIV, and they have to be connected to an NPIV-enabled SAN. So that means your SAN has to adhere to an NPIV topology. One of the really cool things about Virtual Fibre Channel is it's actually possible to live migrate a virtual machine that uses Virtual Fibre Channel. But in order to make that happen, there are some underlying requirements. Specifically, the host that you're going to live migrate the virtual machine to has to have host bus adapters that can be used for fiber channel communications. That's a very logical requirement. But also, each host bus adapter has to be assigned 2 worldwide names in order to facilitate live migration. And the reason for that is because unless you've got those 2 separate worldwide names for each host bus adapter, then connectivity would be momentarily lost to this fiber channel storage during the live migration process. Having 2 separate worldwide names keeps that from happening, so you can truly do a live migration without losing connectivity to fiber channel storage. Earlier I mentioned that there were a lot of scalability improvements in HyperV. Some of those scalability improvements are related to the hypervisor as a whole, and others are specific to clustering. So I want to show you some of the scalability improvements to HyperV as a whole, compared with what we had with HyperV 2.0. So in HyperV 2.0, there was a maximum of 4 virtual CPUs that could be assigned to a virtual machine. In HyperV 3.0, that goes all the way from 4 on up to 32 virtual CPUs that can be assigned per virtual machine. The memory that can be assigned to a virtual machine has also dramatically increased. We went from 64 gigs maximum in HyperV 2.0 to 512 gig maximum in HyperV 3.0. And also, maximum virtual hard disk size. That was 2 terabytes in HyperV 2.0, which was pretty good. And in some ways, that limit still exists in HyperV 3.0, but Microsoft has introduced a new virtual hard disk file called VHDX. That's an XML-based virtual hard disk. And if you use this new format, which you don't have to, you can continue to use the legacy virtual hard disk file, but if you do use VHDX, the limit for the maximum virtual hard disk size goes all the way up to 16 terabytes. So those are a few of the scalability improvements with regard to the hypervisor as a whole. So Microsoft has also made a lot of improvements to cluster scalability. To show you what I mean, the maximum number of virtual machines per host that can be powered on at any time in HyperV 2.0 was 384. That's quite a few. But in HyperV 3.0, Microsoft increased this limit to 1,024. So you can have over 1,000 virtual machines powered on at any given time on a host within a cluster. So the maximum number of virtual machines in a cluster, in HyperV 2.0, you could have 1,000 virtual machines per cluster. In HyperV 3.0, that limit's been increased to 4,000 virtual machines. The maximum number of hosts per cluster. In HyperV 2.0, you could have a cluster made up of 16 hosts. In HyperV 3.0, that same cluster can accommodate up to 63 hosts. So that really opens up a lot of possibilities with regard to what you can do with that cluster. This makes distance clustering a lot more practical. You can have cluster nodes in other locations. The maximum amount of RAM per host server. In HyperV 2.0, you could have 1 terabyte of RAM. That's doubled in HyperV 3.0. Now you can have a full 2 terabytes of RAM per host server. So Microsoft has really made some great scalability improvements for clustering in HyperV 3.0. One of the big features in the original HyperV release was snapshotting. Snapshotting lets you take a point-in-time image of a virtual machine so that if something goes wrong later on, you can revert back to that point in time very, very quickly. Snapshotting is a great feature, but there are a couple of downsides to using snapshotting with virtual machines. For one thing, as you accumulate virtual machine snapshots, read performance can be impacted tremendously. The more snapshots you accumulate for a virtual machine, the worse read performance can become because of the way that differencing disks are used. The problem with that is that you can eventually go in and clear out the snapshots that you don't want anymore. But in HyperV 1.0 and 2.0, you had to actually shut down the virtual machine before you could do that. Now in HyperV 3.0, you don't have to shut down the virtual machine to do snapshot maintenance anymore. You can actually merge snapshots while the virtual machine is running. So that's a very welcome change to HyperV 3.0. So another feature that's gotten almost no press, but that I think is really cool, is the ability to hot add resources. Hot adding resources refers to the ability to add certain hardware resources to a virtual machine while it is running. This is something that's totally new to HyperV 3.0. It didn't exist in any of the previous versions of HyperV. And the resources that you can add are memory and disks. You can actually go in and add memory or add disk resources to a virtual machine while it's running without having to take that virtual machine offline. Now, CPU cores unfortunately can't be hot added. That is something that you can do in VMware, but unfortunately it's not something that can be done in HyperV 3.0. Another new feature in HyperV 3.0 is something called NIC Teaming. NIC Teaming allows you to combine multiple network interfaces into one logical network interface. There are a couple of benefits to doing that. First of all, the logical interface that you form has higher bandwidth capabilities than any single NIC could have because it takes the aggregate bandwidth of all of the network adapters within the team and treats that as one single connection. The other advantage is that you establish a degree of fault tolerance because if any one of the hardware NICs fail, then the connection continues to function because the other NICs within the team are still functional. Now, when I say that NIC Teaming is new to HyperV 3.0, that's not entirely accurate. HyperV 2.0 did support NIC Teaming, but only at the hardware level. You had to have proprietary hardware that could establish a hardware-level NIC team, and that was only available from Intel and Broadcom. With HyperV 3.0, this happens at the software level, and you can actually use commodity NICs, and those NICs can even be from different vendors. So now it's possible to create a NIC team very, very inexpensively without having to delve into specialized hardware. Another new feature is deduplication at the file system level. Now, this isn't technically a HyperV feature, it's a Windows Server 2012 feature, but it's designed to work with HyperV. So, file system level deduplication allows you to deduplicate all sorts of things. In a HyperV environment, some of the things that might be deduplicated are VHD libraries, ISO files, and even live VHD volumes. Deduplication is great because it can reduce the amount of storage that your virtual machines consume. I mean, if you think about it, if you've got a host server that has a dozen virtual machines, and those virtual machines are all running the same operating systems, well, there's a lot of redundancy there with regard to operating system files. So if you perform deduplication, you can greatly reduce the amount of physical storage space that those virtual machines consume. One of the benefits to that is that it can make the use of solid-state storage a lot more practical. Solid-state storage is great because it tends to be a lot faster than other storage mediums such as SATA drives or SAS drives because solid-state drives they don't have any moving parts, so they aren't limited by mechanical constraints. In recent years, the prices of solid-state drives have dropped so that the price of the drive itself is on par with other types of drives such as SATA or SAS, but the cost per gigabyte is still a lot higher because the drives have a lower overall capacity than SATA or SAS drives. So if you can reduce the amount of space that your virtual machines consume, then you might be able to get away with implementing solid-state storage and seeing that performance gain without spending a whole lot of money beyond what you would normally spend for traditional hard drives. Another new feature is SMB Storage Support. With previous versions of HyperV, you had a couple of options for storage. You could store virtual machines locally using direct attached storage, or you could use iSCSI or Fibre channel. Now with HyperV 3.0, you also have the option of putting virtual machines on an SMB file share. But there are some limitations that you need to be aware of. First of all, legacy SMB isn't supported. It has to be a specific SMB version. Also, your ability to scale the use of virtual machines on SMB storage is limited by the bandwidth that's available. So this is primarily something that's going to be used in smaller organizations or for small-scale deployments. But that's not to say that SMB storage can't be used in larger environments. It's just that if you want to use SMB storage in a large environment, you have to have high-end hardware with lots of bandwidth to make that feasible. I mentioned earlier that a lot of the enhancements in HyperV 3.0 revolved around clustering. And another enhancement that's related to clustering is something called affinity and anti-infinity rules. The basic idea behind this is that when a failure occurs within a cluster, you never know where those virtual machines that were running on the failed server are going to fail over to. Sometimes, though, you might have a need for certain virtual machines to stay together. Those virtual machines need to fail over to a common host. That's where affinity rules come into play. Affinity rules can make sure that those virtual machines all stay together during the failover and that they end up on a common host. On the flip side, you might have regulations or business requirements that say that certain virtual machines should never exist on the same host together. One practical example of that is domain controllers. You never want to be in a situation to where all of your virtualized domain controllers exist on a common host, because if that host failed, all of your domain controllers are gone with it. So anti-infinity rules can keep certain virtual machines from ever failing over to a common host server. So affinity and anti-infinity rules are new to HyperV 3.0. Something else that Microsoft is doing is something called virtual machine prioritization. The idea is that sometimes if a failure occurs, the virtual machines might fail over to a host that's already overloaded, and that host may not have enough resources available to run all of the virtual machines that it was previously running, plus all of the virtual machines that failed over to it. So in those types of situations, it becomes possible to prioritize virtual machines so that the higher priority virtual machines start first. And then once all of the high priority virtual machines are up and running, then the lower priority virtual machines start up one at a time until you reach the limit of what the host server is capable of running. So those are a few of the cluster specific features that are new to HyperV 3.0. Another cool feature is offload data transfer support. If you really stop and think about the nature of virtualization, it's that a single physical host can accommodate multiple virtual workloads, but the flip side of that is that all of those virtual workloads have to share a finite amount of hardware. So the virtual machines have to be configured in a way that prevents any one virtual machine from consuming excessive hardware resources. One of the problems with this is that certain operations tend to be resource intensive, specifically copy operations. So normally when you do a file copy, you're generating a lot of disk I/O. But in a SAN environment with HyperV 3.0, it's possible to offload copy operations to the SAN hardware using offload data transfer, or ODX as it's often referred to. This lets the storage hardware do all of the heavy lifting and all of the I/O intensive operations so that your virtual machines don't have to. The nice thing about this is that ODX support is built into HyperV. There's no enable ODX button that you have to click or no option that you have to configure. If HyperV detects that you've got hardware that supports ODX, it will use that hardware by default without you having to do anything to enable that functionality. So one last feature that I want to quickly talk about is the Extensible virtual switch. HyperV, since the very beginning, used something called virtual network switches to manage network connections to virtual machines. The problem with these virtual switches is that if you used any kind of management or monitoring software to monitor your switches, they saw HyperV virtual switches as almost a black box. The management software couldn't see into those virtual switches in order to do any sort of management or monitoring. This is going to change with HyperV 3.0 because Microsoft has made the virtual switches extensible. This means that the vendors can actually write code that plugs into the HyperV virtual switch to make it so that their software can go in and monitor or manage virtual switches the same way that it would manage a physical switch. So this is going to greatly extend your management and monitoring capabilities. So as you can see, HyperV 3.0 has a lot of great new features, and the nice thing is I've only scratched the surface. There are many, many, many other features beyond what I've been able to talk about within this presentation. So I have to say that with version 3.0, HyperV has finally arrived. It's going to be a great product, and I'm really excited about using it in a production environment once it's finally released. So that's going to do it for me. I'd like to thank everyone for tuning in.